everyone. In this video, I want to provide you with an overview of lists in Python. Lists are one of the many built-in data structures that Python offers right out of the box. If you've worked in another programming language before, like Java or C++, you've probably worked with something similar to lists. Lists are like array lists in Java and vectors in C++, in that they are similar to arrays, but they can grow and shrink in size. So let's start by taking some notes related to lists. So first off, what is the official definition for a list? Well, I like this short one, which is a list is a sequence of items. Now, you've probably worked with a lot of lists in your life, right? Every time you use Excel, for example, you're working with lists. Every time you make a grocery list to go to the store and pick out items to make your favorite dish, you're working with a list. Or maybe even a to-do list, right? It's just a sequence of items where order does matter. Now, that list can be one-dimensional, for example, a single row in Excel, or it can be multidimensional, like 2D, for example, a grid or a spreadsheet in Excel. We're going to start with one-dimensional lists. So I'm going to say something like, think about 1D lists like, say, a single row or a single column in Excel. Let's take a look at how you could declare a list in Python. So you can declare a list using hard brackets and a comma-separated list of values. And you may hear me say value or element. Either one of these describes a single data point or a single piece of information inside of a list. So let's declare a list of integers. I'll call it list ints. And I'm going to initialize this list using hard brackets. If I don't put anything inside of these hard brackets, then this is an empty list. But if I want, I can initialize this list to have some initial values or initial elements. So let's say I'm going to put in 4 numbers, 0, 1, 10, and 20. So now my list of ints has 4 elements in it. Now, what's the beauty of working with lists? Well, using this one variable name here, I can essentially access 4 different pieces of data. Instead of having to store each one of these pieces of data in its own variable, I can instead put them in a list, keep one variable name, which represents the list, and then access individual elements or items in that list using an offset from the beginning of the list. So let me explain. There are unique indexes for each element in the list. So these indexes are 0-based, meaning the first element is at index 0, and the last element is at index n-1. And I'll be very clear here, where n is the number of elements in the list. So for example, we have 4 elements in this list, 1, 2, 3, 4. So 0 is at index position 0. 1 is at index position 1. 10 is at index position 2. And 20 is at index position 3, which happens to be n-1. 4 minus 1 is 3. Something that's kind of fun about Python is it also has negative indexes. This sounds confusing and crazy, but it's actually fairly straightforward and fun. So let's start with the very end. So the last element in a list is at index -1. The second to last index is at index -2, and so on and so forth. So here we see that the first element in the list is at index 0, and it's also at index -n, where n is the number of elements in the list. So let's try out this fun indexing scheme. So let's say I want to do print list ints sub 0. So this should print 0. And it does. If I were to change the 0, say, to 100, then this is going to print 100. Now let's try working with these negative indexes. So let's try printing out list ints sub -4. This should also give us 100, and it does. Awesome. Working with list indexes is really important because you often want to be able to randomly access any one of these elements using your variable that represents your list. All right, let's dive into some more details of working with lists in Python. So, unlike other programming languages, or at least the ones you've probably worked with, C++ and Java, types can be mixed in a list. So let's declare another list. Let's call this one list numbers. And this list of numbers is going to have both integers and floating point numbers in it. If I were to print out the type of list numbers, what do you think would show up? What is the data type of list numbers? So we see that the type of list numbers is list. It doesn't say anything about the type of the individual elements in this list. And this is also because the individual elements in a list can change. So I'm going to write a little note here that lists are mutable, which means they can be changed after they've been declared. So let's say I don't want that first element, 0, to be 0 anymore. Maybe I want list numbers sub 0 to be the string hello. It looks kind of weird, but I can do this because lists are mutable and lists can store a mixture of different types. So now I've got string, float, int, int. All right, let's take a look at how programmatically we could figure out how many elements there are in a list. Because we know that lists can grow and shrink in size, just like Java array lists or C++ vectors, programmatically we should be able to figure out how many elements there are in a list. So use the built-in function len to find out how many elements are in a list. So I'm going to print out len list numbers. So list numbers has 1, 2, 3, 4, 5 items in it. I print out len list numbers and I see those 5 elements. So why this is really useful, as I said, it tells you the number of elements in lists, but it can also be used for indexing. So let's say I add another element to the list. So I can do that with list numbers dot append. I'll say another element. So now, programmatically, I might not know exactly how many elements are in the list, but I can find out with len. And if for some reason I needed to get the last element in the list, then I could use len kind of as my n, and then subtract 1 to be able to programmatically always figure out how many elements are in the list. So let's try it. So let's print out the last element in the list. Suppose we don't know at runtime, or excuse me, suppose we don't know at compile time exactly how many elements are in the list. So I can do this. Print list numbers sub len list numbers -1. And this is always going to tell me what the last element in the list is. All right, some other things related to lists. We can declare an empty list. Here's an empty list. There's nothing in it. I can print out the empty list and I won't see anything in it. I could print out len, get the length, the number of elements in the empty list, and it would tell me that there are 0 elements in the list. No surprises there. We can have lists of lists. I was kind of alluding to this earlier. So this would be like 2D or ND, like multi-dimensional lists. Let me just show you an example of what this looks like, and then in another video, we're going to go through the details of working with lists of lists, because they can get kind of crazy kind of fast. Let's say that I have a nested list, and it's a list where it has elements in the list that are also lists themselves. So let's say the first element of the list is the list with two elements, 0, 1. And the second element in the list is the list with the singleton 2. The third element in the list has the singleton 3. The fourth element in the list has two elements, 4 and 5. And perhaps the last element in the list is the empty list. Now, if I were to print out the length of the nested list, what do you think is going to print? So let's take a look at it. Here's our outermost bracket for our list. How many elements does it have? 1, 2, 3, 4, 5. There we go. We see 5. Now, let's see what would print out if, say, I did the length of nested list sub 0. Okay. That's the first element of nested list. The first element of nested list is this sublist or nested list 0, 1. How many elements are there in this list? Well, there are 2. Let's see if we have 2 print. Indeed, it does. All right, that's just a brief overview of lists. I'm going to go through them in more detail in another video and talk about how you can imagine them like a grid or a matrix with rows and columns, and we'll go through some common algorithms for iterating over nested lists or two-dimensional lists. All right, now it's time to learn about how we can iterate through lists. Right now our lists have been small and we've known the size of our list, but at runtime, we're probably going to have different sizes of lists if, say, we're loading data from a file or perhaps from the web or even from the user. So we need to be able to write really extensible code that can operate on any list. So let's start with a simple example. Let's say I have this list called candies, and it's got some fun candies listed in here as strings. All right, I can simply print out candies. There are 4 candies, but I can also iterate over each candy one at a time and print it out one at a time using our nice for each loop. So for candy in candies, print candy. So recall that this is going to iterate over each element in a sequence. Recall our definition of a list. A list is a sequence of items. Our for each loops or our for in loops in Python are really handy for iterating over elements in a sequence. So candy is going to take on each string value in the list of strings called candies. So now we're going to get each candy printed out one at a time. Now, this is really helpful if we wanted to do something, say, with each one of these strings. Or if we were iterating over a list of numeric values, perhaps we wanted to do something with each numeric value, like maybe double the value or accumulate the values, do something like that. All right, now let's work with a while loop and see how we can print out each candy using an index. So this is just going to be another way to write this for loop where we can get access to the index of each element. So let's declare a loop control variable, I is assigned 0. While I is less than length of candies, because let's assume candies can grow or shrink in size. We don't know it's always going to be 4, so we should programmatically figure that out. So let's print I, comma, candies sub I. So we can see the index and the value at that index. We mustn't forget our progress towards our Boolean condition being false. So I plus a sign 1. And now we're going to run this and see not just each candy, but also its index position. All right, let's try one more way to write this loop. We're going to also have access to the index of each candy using a I loop control variable, but we'll do this with a for loop and a range. So let's start I at 0, for I in range, len candies, we'll print out the exact same thing. Just another way to write the same loop. And there it is printed again. All right. Next, let's go through some common list operators. So let's start with list concatenation. So this is adding two lists together. So let's say I have my candies, and now I want to add some candies from another list to my current candies list. So let me print out candies just so we can see what it starts at. And then I can append and overwrite to candies all of the elements in another list. Let's say in this list I have M&Ms and Starburst. So this is going to modify my candies list and add two more strings to the end of it, as you can see here. We also have list repetition. So this is repeating elements in a list. This is actually really, really cool. Let's say I have a big bag of candies and it's full of 5 Twix. So I'm going to use 5 and the repetition operator to essentially multiply this element, or if I had multiple elements in here, the contents of this list by 5. So I'm going to get 5 Twixes. Let's say I had 2 in here. Maybe I have Snickers. We're going to see that we're going to get Twix, Snickers 5 times. So this is a really fun way to initialize lists with some values. All right, next, this is really important, especially for data science. So let's do list slicing. So this is how we can grab sublists of lists. So let's say I only want to grab, say, the elements at index positions 1 and 2. So that would be, here's 0, 1, 2, 3, 4, 5. So index positions 1 and 2 would be Reese's and Oreos. So let's print out candies sub 1 through 3. And we see Reese's and Oreos. So this colon here is the slice operator. And here's what you need to know about the slice operator. So the start value is inclusive and the end value is exclusive. So 1 is my starting index. I'll change these from value to index just to be very, very clear. And 3 is my end index. So inclusive of 1, 2, because that's in between 1 and 3, but exclusive of 3 because it's the end index. Something fun about the slice operator, the colon, if you ever need a copy of a list, you can simply use the slice operator with no start or end indices. So for example, copy of candies would be candies sub, grab all the elements in the list. So slice the whole thing. This would give you a copy. So now if I were to say print out copy of candies, I would see the exact same thing. But let's say before I print out copy of candies, I say change the first element to be Twix in all caps. I'll print out copy of candies, and I'll also print out candies. So here's copy of candies. The first element is Twix, but here's the original candies. The first element is Twix in a different case. So here I have successfully made a copy of this list. Now, later we'll talk about the difference between a shallow or a deep copy. It's important to note that this colon operator is performing a shallow copy of the list. But we'll talk more about that in a video down the road. All right. So this is a great introduction to working with lists in Python. We've really only scratched the surface. For example, there are a lot of list methods that you can explore. So if you have a list such as candies and you press dot in a development environment like VS Code, where you're going to get some code completion suggestions, it's going to often provide you with all of the available methods that you can call related to that list. So for example, we've already seen an example of append. We can also remove an element. So let me show you the documentation for remove. So we can specify a value, and if that value is in the list, then this is going to do an in-place removal of the first occurrence of that value. So there's a lot of fun things to explore related to list methods. Like here's a reverse, here's a count, and insert, all sorts of fun things to explore. All right, take some time and play around with candies using some of these methods. See if you can guess what they do before you run them, and then run them and check your guess. All right, that's it for our introduction to lists. Thank you for watching.